So intermolecular forces, the forces between the molecules. So we have dipole forces, dipole induced dipole forces, and London dispersion forces. This was the beginning, the start of the topic. Now, the last week we discussed why, or the trend in the melting or the boiling point, basically the boiling point, because most of them are in a liquid or a gaseous state. So when we compare the boiling points of group 6 hydrides, group 7 hydrides, the trend. So what we observe, first hydride will have a higher boiling point for group 5, group 6 and group 7 as compared to any other hydride in their group. And then the boiling point will decrease and then the boiling point will increase. So what is the reason why there is a decrease first? So first why it decreases, because this is having hydrogen bond and here we have dipole force in hydrogen sulfide. But from hydrogen sulfide to hydrogen selenide, we have dipole induced dipole force. And dipole induced dipole forces increases as the number of electron increase. So because this is having more electron, that's why it will have higher boiling point. Same thing when we compare hydrogen fluoride with hydrogen chloride. So we observe the boiling point decrease. Why there's a decrease in boiling point? Because in hydrogen fluoride, there's a hydrogen bond. In hydrogen chloride, there is a dipole force. And then hydrogen chloride and hydrogen bromide, what we observe the hydrogen bromide is having a higher boiling point than hydrogen chloride. Reason for that, because in hydrogen bromide there are more electrons, so they will have greater dipole induced dipole force, weaker dipole force, but overall the net force, dipole induced dipole force, will be higher as compared to dipole force, which cause or result in a higher boiling point. Then solubility of the substance, solubility of the ionic compounds. So solubility of the ionic compounds depends on number one, the lattice energy. And hydration energy. If hydration energy is more than or equal to the lattice energy, the substance will dissolve. And if the hydration energy is less than the lattice energy, the substance will be insoluble, does not dissolve. So it depends on two factors, hydration energy and lattice energy. But what is the meaning of hydration energy and what is the meaning of lattice energy? Look, the term lattice energy means when ions in the gaseous state form a compound. So when ions are there in a gaseous state and these ions will form a compound. So when bond forming is there, bond forming is exothermic. So it will release energy and that energy is known as lattice energy. And what is hydration energy? The term hydration energy means when ions form bond with water molecule, and bond forming is exothermic, we call that energy release, we call that as hydration energy. So example, what will happen in this, you will have ions in the gaseous state and they will become ions in aqueous state. So when ions in gaseous state change into ions in aqueous state, we call that energy as hydration energy. So example, you have a sodium ion which is positive and it is in a gaseous state, and you have a chloride ion which is negative and it is also in a gaseous state. So what happens when these ions come closer to each other? What this will result in a formation of solid sodium chloride. So when this solid sodium chloride is formed, because it is a bond forming, and what we call this bond forming? Bond forming is exothermic and it will release energy because it's a bond forming, and overall this compound now is in a solid state. There will be lot of ions, millions or trillions of ions, but we are taking only the simplest ratio of the ions present in the structure. So to form a sodium chloride crystal, we need the ratio between sodium and chlorine is 1:1. So what it will form? It will form a solid compound. So this solid compound, when it is formed, as ions come closer to each other, so it will release energy. Because why it release energy? Because the bond forming is exothermic. So when these ions come closer, for ions, as they form a bond, they release energy. So energy will be released. Example, the overall energy which is released in this case, say 700 joules, kilojoule per mole. So 700 kilojoule per mole. Negative sign shows it is an exothermic. So if 700 joules of energy is released when sodium ion and chloride ion form a bond with each other, how much energy is required to separate them? If this is the amount of energy released when the two ions come closer to each other, so which is 700 kilojoule per mole, how much energy is needed to separate these ions from each other? So we need plus 700, like we have to supply this much energy to separate these ions from each other. So this is about the lattice energy. Lattice energy is always exothermic because it is a bond forming. Hydration energy is also exothermic because it is also a bond forming. But what is the meaning of hydration energy? Look, for example, I add a crystal of sodium chloride, a solid sodium chloride inside water. So when I add this solid sodium chloride inside water, what happened? The water molecules have poles. Dipoles are there, permanent dipoles are there, in which hydrogen is partial positive and oxygen is partial negative. So we have water molecules with net dipole moment is there because it's a bent or a V-shaped structure. Now what happened? This oxygen which is partial negative, so where it is attracted, this oxygen is attracted towards sodium, and hydrogen, which is partial positive. So this hydrogen, the partial positive, is attracted towards chloride ion. So when these dipoles attracted towards the opposite ion, so they try to form a bond, and what we call this bond formation, when water molecule form a bond with the ions, so we call that energy, because bond forming is exothermic. So when they try to form a bond, they will release energy. So the total energy example which they release is equal to minus 700, minus 800. Why negative sign? Because it is exothermic. So what happened when water molecules try to form a bond with these ions? The bond forming is exothermic, so it releases energy. And that energy which is released is known as the hydration energy. And if the hydration energy is higher, like example, minus 800 means like 800 joule of energy is released. So that 800 joule is more than the lattice energy. So if it is more than the lattice energy, what will happen? This will cause the sodium ion to separate from the chloride ion, or when ions separated from each other, the substance will dissolve. Is it clear? So if the hydration energy is more, that energy which is released when the water molecule try to form a bond with ions, the energy which is released by this bond formation is absorbed by the ions, and ions are separated from each other because this energy is more than the lattice energy, so the substance will dissolve. Is it clear? How ionic compound dissolve in water in terms of lattice energy and hydration energy. Is it clear to everyone? So same thing, example, another example I'll give. Say you have potassium chloride. Potassium chloride is also soluble. I'm just taking that as an example to explain the idea. Like you have potassium chloride. So potassium chloride means it contains potassium ion and it contains chloride ion. Now what happened when potassium ion and chloride ions come closer to each other? They will form a bond and they release energy. Example, they release minus 1200. Negative sign shows it is exothermic, and 1200 kilojoule per mole of energy is released. So what it shows, the lattice energy, when ions come closer to each other, that energy is called lattice energy. So we have a potassium ion and chloride ion, which form a solid potassium chloride with a lattice energy of 1200. Negative sign because bond forming is always exothermic. So hydration is also exothermic, lattice is also exothermic. Now what happened? This molecule, this crystals of potassium chloride are added to water. So when we add these crystals to water, the water molecule in which the oxygen is partial negative and hydrogen is positive, so oxygen will try to form a bond with potassium. So, and chlorine will try to form a bond with hydrogen, and bond forming is exothermic. So what it result? It result in a release of energy. So it will release energy. Example, the total energy, it's because different ions release different amount of energy. Hydration energy will be different. But example, this release, say total, the hydration energy is minus 900. Negative sign shows that this is exothermic, and 900 is a joule of energy, kilojoule per mole, which is released. So what will happen? This is a hydration energy. Will it dissolve? So it will not dissolve. Why it will not dissolve? Because this, to separate the ions, we need 1200. But when hydration energy, the energy release is only 900, that is not sufficient to separate these ions from each other. So this substance, theoretic, practical values are different. I'm just taking that as an example. So in this case, the potassium chloride will be insoluble or does not dissolve. And as we go down the group, like example, we have lithium, then sodium, potassium. Lithium is plus, sodium is also +1, potassium is also +1. Which one you think will have a higher hydration energy? Hydration energy means the energy release when water molecule try to form a bond with the ion, positive or negative. Which one you think will have a higher lattice energy, hydration energy? So lithium, so basically what happened, the hydration energy, as we go down the group, the hydration energy decreases. And what is the reason for that? Because here, when you make a water molecule, I should make it other way around, because oxygen is attracted instead of hydrogen. Oxygen is partial negative. So here the ions can, the partial positive and the ion, positive ion, and the oxygen partial negative can come very close to each other. So they have a strong bond. Whereas sodium, which is larger in size, because basically the attraction is towards the nucleus. So as it is larger in size, there will be attraction, but weaker attraction as compared to that of lithium. So as we go down the group, what we observe the hydration energy decreases. So this is happening for all the groups, group 1, 2, and 3. And it also depends on the charge. Greater the charge on the ion, greater the hydration energy. Like example, if we have, say, magnesium, which is +2, or calcium, which is +2, so they will have greater hydration energy as compared to lithium or sodium, because they have +1 charge, where calcium and magnesium have +2 charge. So hydration energy decreases as we go down the group. If we need enthalpy change of a solution, enthalpy change of a solution, so the formula to calculate the enthalpy change of a solution is equals to hydration minus lattice. That's the formula which we use to calculate the enthalpy change of a solution. And if enthalpy change of a solution is negative, it will be exothermic, so it will be soluble. If enthalpy change is negative enthalpy change of solution. So if enthalpy change of a solution is negative, ionic compound will dissolve. And if enthalpy change of a solution is positive, the ionic compound will be insoluble. But when we find the enthalpy change of sodium chloride, this is enthalpy change of a solution. So when we find the enthalpy change of a sodium chloride, we find it is plus 5 kilojoule per mole. So it is positive, but it is only plus 5 kilojoule per mole. So what does it mean? Means it is an endothermic. But so how, from where we supply this energy, that is commonly how you supply, like you take a container, you take a glass and you fill this glass with water and you add a common salt, sodium chloride, to this. So when you add a common salt or sodium chloride, when you add, it will not dissolve or mix by itself. What you have to do, you have to stir. So when you stir, actually your stirring is also supplying energy, and plus 5 kilojoule per mole is supplied by stirring. So that is why sodium chloride will dissolve. So even though it is positive, but sodium chloride can dissolve in water because very small value for the change in, or energy change or enthalpy change, and which can be supplied by stirring. Is it clear?